So, welcome to the first Enfuse podcast, everybody out there in big data land. This is the first podcast that Enfuse is putting together. So, in this specific podcast, we're going to be talking about how to learn big data, which is a pretty overarching thing. Big data is a lot of things, and so we'll try to whittle it down to the perspective of kind of someone that's just coming directly into the big data industry with a lot of software development, engineering experience, things like that. But we're going to take that angle on it, and then I'll kind of add in brief bits here and there of what my experience was, because everybody's experience getting to where they are in the big data industry is taken different paths. And it's so interesting sometimes, at least for me, to talk to different people in this space because they come from developers to DevOps people to HR people. I met a lady once who worked at, her entire degree was like hotel management, right? And so she had gotten a job there. She needed something off the bat. So I think she started working at Marriott or something like that. And somehow she had gotten involved with the data side of things as far as the reporting she needed to help support her job. And I don't know the path from that, but eventually she got into the data side of things, and she became a big data engineer within Marriott itself. So she went off managing the hotel to writing the software for Marriott to do big data things. So everybody's path into the space is extremely varied. And since big data is such a large ecosystem of different things, sometimes people are pigeonholed into different aspects of it, whether that's data science or engineering or development or data ops, cloud ops, every other ops you can think of. Everybody has their little narrow piece. And that's why I think it makes it very difficult to just say, okay, I want to be in this space or I want to be in this industry. Where do you start, right? Because in my case, at least with big data, the entire definition that I run by with big data is at least that the size of the data itself becomes the problem. So practicing or getting to know these big data services locally is almost misleading, after a while. Nobody wants
Yeah.
to pay for, terabytes and terabytes of Spark clusters to learn how to do, MapReduce code.
Yeah. And the biggest thing for me was to where do I start? I mean, this thing's so big. Where do I start, and kind of how do I enter this space kind of gracefully from where I was to where I want to be?
Oh, for
And
sure.
maybe that's a good segue into who are we? Why are we talking? What are we doing here? What are our qualifications?
Right. So Enfuse, let's start off with Enfuse. Actually, let's give anybody that's listening a good idea of what we do, and then we'll go into who we are. So
Sounds good.
Enfuse itself is a professional services company that specializes in I'd say any kind of data intensive application development effort. And that in itself is overarching. So if you boil that down, it's really we're working in big data pipelines, transporting data from point A to point B, in real-time enrichment, from stream processing to batch processing to generic or general event-driven architectures and applications within those. But what we do specifically is, or how we came about is, there's a ton of different companies out there that will do like big data architecture, DevOps or sysadmin kind of things. You need a Hadoop cluster, you need an architecture. There's going to be any number of companies out there that are going to say, we can set that up for you, deliver it to you, here you go. And that industry in itself gave rise, I would say, the early 2010s, because Hadoop itself, which is kind of the core of big data, was not super trivial to set up. And so you had a lot of professional services companies coming out helping clients get their environment set up, and then they would leave, right? So that's when it was either make it or fail for those companies, because then they had to either train new resources to be able to actually utilize those services and write applications on top of those, or they had to retrain existing in-house people to be able to use that. And that's an extremely difficult thing to do. That's where Enfuse comes in. We come in as the parachute team of, I'll be biased, obviously, but of probably the best big data developers that I know of easily. Come into these clients, we pair with them, we teach their data engineers the next generation of data engineering, which is really big data software development. Um, I think when data engineers get pigeonholed into SQL a lot, and we come out and we train them and we teach them and we implement production software into those clients' environments. But at the same time, we're training their people to be able to add features, fix bugs, maintain everything throughout that process. So that's my overview, Enfuse, along with a lot of other things that we do. But in my mind, that's what we do. And then Nate will actually tell you his experience. I guess you can do that now. What's your experience
Yeah,
been
yeah.
like
I'll
so
give a short intro. Hi, I'm Nate Olson. I'm a senior software engineer for Enfuse, and I think what Enfuse really does really well is offers data as a first-class citizen in your enterprise architecture. Our goal is to come in there and make data available to everyone, and really enable your teams to get up and moving quickly and pair alongside you to be able to establish really clean code, clean architectures that'll scale really well and be able to access your data at lightning speed. So I think another thing that we do really well from the consulting aspect is our pair programming. We're huge on it. Before this, I really hadn't been indoctrined into it, and I think all good things, take more than one set of eyes. So I think that's another thing that sets Enfuse apart. So
for sure, pairing is expensive, man. When you go to a client and say we want to, you're going to need at least 2 pairs or something like that. It's always like, why do we need 2 pairs? And my well, I don't want to name any names, but there are large companies out there that don't pair, and these large companies that will outsource different work to be brought in for sometimes mission critical applications, and they just have some solo contractor working on it. No tests are created, no nothing, and these things become ticking time bombs eventually. So at least with pairing and test-driven development, getting as much code coverage as we can into those applications is another safeguard against things going wrong. So Nate's intro, my name's Kalen. I haven't even said that yet. Kalen Humphreys. I'm co-founder of Enfuse. My background is all big data, really. Academic-wise, my background is completely mathematics, and then I ended up in big data. I think my original kind of way into big data is interesting, because when I was in graduate school and I had 2 months left, right, to get a job in this space, or in any space actually, at that particular time, I didn't care, right? I would have shoveled snow
yeah,
because I had a wife and a kid that needed to, stay in the
priorities, man,
elements, right?
priorities.
So I remember a couple months before graduating, and I was throwing off my CV everywhere, and it was just a lot of academic stuff for the past 6 years, and then a couple, software jobs before that, but nothing recent, right? And I remember the one return I got from I think it was like ZipRecruiter or something like that, was a Smoothie King in Fort Lauderdale needed a regional manager, and they said, we've looked at your experience in your education, and we think you'd just be perfect for a general manager of Smoothie King in Fort Lauderdale. And I told my wife, if this is why I went to school for so long, then we've got some big issues coming up, some big problems.
The
So
Smoothie King.
the Smoothie
Nice.
King, right? So what I did is I just started calling around really to a lot of my friends that were in the industry, right? Not necessarily the big data industry, but any industry in technology, because that's the way I wanted to go. And I had thought automatically that I would be in the data science part of things because of my mathematics background. And I called a buddy of mine up, and he said, my boss is starting this spin-off company. Do you like big data? And I was like, I love it. I love big data. I can't have enough, I had no idea what it even meant. So I read like crazy, and then he introduced me to this guy, and then introduced me to that guy. And then I got started at a company called ZData finally. And ZData was all a lot of, at that time at least, a lot of the cloud native offerings for things like Hadoop didn't exist, right? The marketplace offerings that are prepackaged and configured with all these nice DevOps tools didn't exist. And so all that stuff had to be set up manually for different customers. And so that's essentially what we did. We set up large Hadoop clusters, configured them, Spark clusters, Yarn, all that type of stuff.
Hmm.
That is now automated, right?
Yeah. So no Terraform, no
No,
data proc, no EMR.
nothing nice. I mean, there was Puppet at the time, but Puppet and Chef, of course. But the Terraforms and in the things that integrate into specific, I'd say, cloud APIs for deployments and stuff, were just like getting legs, right? And so nobody actually used them because it was way too scary to actually spit up your environment with those. So I worked at Zdata for a while, and we went through a number of different clients. And I got on this one client where we were writing pipelines for, right, data pipelines, and that's when I really started writing more Java code. Because as a like DevOps or sysadmin type job, you're not writing a lot of applications, right? You're more writing application scripts and things to spin things up. But I really liked being more in the application development side of things. However, I always wanted to stay at the leading edge, and I knew if I always attached myself to big data and machine learning, then I'd always get to play with the coolest new stuff, right? So after my prior company was acquired by Atos, I spun off on create a new company called Enfuse, and that's all we do. We write big data code, data intensive applications, more or less, right? And, so it's been a lot of fun. But it is weird. The first time I started working with machine learning models and working next to data scientists, which was my original goal, it was so boring, so boring. You get the model up, you're cleaning your data, then you're tuning, right? And it's like, I don't want to do that at all. So I'm so glad that I kind of found a niche where I wanted to, I could excel at. So,
Yeah, it's definitely a cool space. And coming from where I came from in utility industry, pretty boring, regulated industry. That's where I started my software development career. Then kind of went the consultant route and was very heavy front end focused. But I knew that's not where I wanted to live. Right, creating widgets all day and
right.
dealing with the designers. Yeah,
Yeah.
not my thing. So I really wanted to get more involved in data. And I guess my intro to big data land and kind of that back end methodology was through Kafka. And I really had an intense desire to learn Kafka. And I thought it was the greatest thing since sliced bread. And I still think it can cure cancer eventually. But I really thought Kafka was the gateway for me into big data. And now it's opening up a lot of different swim lanes for me to kind of peruse and
For sure.
investigate.
Kafka certainly, I think Kafka probably is the gateway drug for a lot of big data people right now, especially since they've that the Kafka hype train is getting up bigger and bigger, and they're getting more and more funding and more VC and things like that. While like Hadoop and HDFS and Spark and those things that were traditionally kind of the gateway into it are more or less kind of just expected to already be there, right? By whatever cloud environment you're using. And so the more and more that stuff becomes automated, you have this new cool stuff come out. I mean, it's been going back and forth with internally with us at least about Pulsar too. I haven't had much time to read about Pulsar, but one of our guys, Corinne, is completely sold, I think. And
Make
so,
it two.
Nate and Corinne, I haven't even touched it yet, but I do know we need to make some kind of Spring Boot, core or starter for talking with that as a middleware.
Yeah, my goal 2020 is to create some sort of packaging around Pulsar and Spring with another one of our colleagues to go ahead and get that kicked off and have some nice tooling around it. Because really the greatest thing about Kafka is the ecosystem and what surrounds it and the people that surround it. But Pulsar is gaining a ton of traction. But before we go too far into that, let's maybe take a step back and think like, okay, big data history. Give us a short intro on like big data history, like where to start, where to come from, what are the key technologies if you want to get into this space that you really need to understand.
Sure. So big data history, I think for me really starts in theoretically at least in the year 2003, right? When Google or when the two guys from Google, I forget, Jeffrey Dean, I want to say, and someone else released the MapReduce paper. right? And that entire paper was based around how do we process data at extremely large distributed scales. So nothing had yet been implemented, just like any kind of white paper. But the idea was there, and so I think that's what kicked off the big data hype train, more or less. So prior to something like Hadoop, the best you really could do is scale vertically, right? And if you go back in time in the late 90s, early 2000s, scaling vertically was expensive, super expensive, even more expensive than it is now. If I needed a terabyte of memory, was that even possible? You know what I mean? Within one instance. And if it was, you're going to be paying top dollar for it. Another point of that is whenever you're stuck in that vertical scaling kind of pattern, there's always opportunity for single point of failure, right? Like in a lot of those databases, a lot of those systems, there's good DR strategies, but that still takes time unless you have really good active kind of scenarios. So with Hadoop, it brought along the concept of scaling horizontally, or distributed computing, where you could pool your resources, whether it's memory, disk space, everything, just by hooking up commodity hardware, right? And with that, statistically, hardware is going to fail no matter what. So the more and more commodity hardware that you hook up to this cluster, the more you replicate your data, the more it's available. So I would say Hadoop, really, and I don't think there'd be any large disagreement that Hadoop is kind of the grandfather of all big data technologies. But people always have to, there's a difference between a Hadoop and HDFS. HDFS is a subset of Hadoop. Hadoop is a term that kind of is an umbrella term, right? It's going to describe everything under the sun when it comes to talking to an HDFS cluster. So things like Hive,
Pig,
Cassandra, Pig, yeah, all of those things that translate nice
Ranger,
syntax, Ranger, everything that translates nice syntax down to MapReduce. That is Hadoop in my mind. And that was another thing when I came into the industry to learn Hadoop, right? There were 60 plus services on top of that. And I thought, how the hell am I going to learn all of these services to help a client? And what I found, someone early on told me, you just keep working, and then like 2 or 3 months into it, stuff just clicks. And that's what happened. You find out that with new technologies, and they have that hype, with the new technologies, as soon as somebody comes up with a good idea for a service on that technology and they get somewhat established, then you have imitators coming up, right? And they're trying to do the exact same functionality that you are, but they're adding extra functionality too. So what I realized along those first 2 to 3 months is there was a lot of overlap, right, between these services. They all had nice syntax, you could query, things like that. But this one had this one thing that this other one didn't, And so I was able to organize things in my mind pretty easily like that. And then comes Spark, right? I'd say that's the second most important thing on the big data stack. Apache Spark is gives you the ability to process data much more quickly than within HDFS and MapReduce, because you're no longer limited by disk speed, since it's ingesting everything into memory. The MapReduce paradigm is still there, but it's just really, really fast, right? And that spun out of Mesos, Apache Mesos, I think in 2009, I want to say. I don't remember. But it was a side project within Mesos that got split out and then donated to the Apache Foundation. So those for me are always the two biggest ones, Hadoop and Spark. When I think about big data, what comes to your mind when you think about big data and the history?
Yeah, so I think my entry point was really HDFS and understanding the underlying file system, right? Kind of separating storage from processing. And then Spark, really, I mean, we use Spark so heavily. It's pretty much our cross-cutting tool across a bunch of different problems that we might have. It can operate in batch, it can operate in streaming mode. So I think it solves a lot of problems that we face in the big data space because of how optimal it performs. I mean,
Right.
It is crazy fast. So if there are two technologies I would say focus on right out of the gate, whether you're a new developer or hey, you're like me and you did like front ends and maybe like Node.js or Spring APIs, and you're like, hey, I really want to do more data intensive applications, those are the two technologies I might start with first. And then, there's also, kind of pivoting into event driven architectures, right? And out of big data comes this event driven architecture where, data at rest is kind of a bad thing, or people view it as one. It may actually not be. It depends on your use case. But the event driven architecture, and for me, probably the key technology to learn right now, the hottest technology, like we've already mentioned, is Apache Kafka. And the, I guess, distributed messaging nature of it. And there are some drawbacks, but maybe for another podcast. But definitely Apache Kafka and kind of how it enables you and pairs really well with the existing technology stacks at your company. And really, I think if we were to say like the technologies, we can almost guarantee when we go into a client that they're going to leverage, it's going to be HDFS, Spark, Java, Spring, Kafka. Like those are your 5 things. If you're a new developer or you're a developer who wants to do something a little different, those are like the 5 technologies that I would key on.
For sure, especially in enterprise situations. I think Java and Spring is, I forget reading some kind of metrics or statistics about how many enterprise organizations utilize Spring as their main Java framework, and the percentage of developers within organizations that use Java and Spring. It's crazy. It's crazy how many different enterprise organizations use that. So to be able to take those engineers at a current client and have them be able to write applications towards these big data services with existing languages and frameworks, I think is huge. So you don't get into the typical scenario where you have, say, a Java enterprise stack. You bring in a consulting company to help you with a big data problem, and there, all of a sudden you have a Kubernetes cluster and stuff written in Go and Docker files that nobody can support at your organization, right? So Java is still going to be the number one thing for us. But it's interesting that when we started talking about Hadoop, because I've been writing some Hadoop internal intro kind of training material for just new onboarding for us, right? And for all of our new guys to kind of go through. And that involved writing I think I wrote a sample word count MapReduce application or something like that. And it was just painful, man. I was like, oh God, this is so terrible. And I realized, the last time I'd written a word count or anything similar, the last time I've written a Hadoop MapReduce app has probably been like 10 years at least, right? And that just goes to show you how quickly this technology evolves, right? Hadoop came out with all these wonderful things you could do, but right now it's primarily poised as just persistent storage that's made nicely to connect to other services like Spark and Kafka and things like that. So whenever anybody asks about writing MapReduce code in Hadoop, I just say, just start off with Spark.
It's probably something better. Probably something better at this point.
Right, because I don't think you'll ever, unless you're coming in to maintain some kind of legacy Hadoop applications, I can't imagine ever writing a MapReduce client that works, or a MapReduce app that works directly on Hadoop. We're just past that point, I think, in big data.
Definitely. Well, like, what about some of the learning materials that, like, I know you just spoke about some of the internal things that we're generating at Enfuse, but like, what about some of the learning materials? Is there good resources online? What should you kind of like hone in on, are the key areas? Because, as an engineer that might be looking to shift their career, it becomes difficult with the amount of time that you have to like what you need to focus on and really ingest.
Yeah. And when we take people on, the biggest things are, how do I say this? How much experience in core Java and Spring do you have? But really, that's any kind of JVM based language, I would say, when you're starting out as a developer in the big data space. Since when we're talking about these distributed environments what makes them run is the JVM, right, on each one of those nodes. So Java, Spring, Kotlin, those kinds of things that, or Java, Scala, and Kotlin, those kinds of things that run on JVMs will help you, at a very core base. But going out there and Googling, Hadoop applications, I wouldn't even do that, right? I just stay away from that. I would go
Yeah.
in and I would start looking up Spark things, but utilize those online courses. I use a lot of Udemy, right? A lot of Udemy. Um, uh, there's also Coursera. There used to be a few others. And then, of course, there's individual certifications you can get through different stacks, right? Which can be okay. But usually, if you're looking to get in, you don't want to spend the money on a certification. Let your company spend the money on you instead to get those certifications. So I would pick up those deals, those $10 classes on Udemy, things like that, and just make sure they've got good ratings and they're pretty popular. The most popular ones are going to stay up somewhat up to date, better than what you'll find on a MapR blog from 10 years ago.
Yeah, there's some really good, from what I found just in my own learning, some really good Spark courses on Udemy that give you a really good high level overview, and then they dig into some specific areas on things that you need to know around data frames and Spark
Yep.
SQL, right? Spark streaming, Spark ML. So you get some nice deep dives, but you understand the overarching picture very well. And then Coursera has some nice free machine learning with options to purchase a certification. So I would really invest heavily into looking something up that you think is going to make sense for you.
Right.
If you're not a visual learner, and you can just pour over docs and get things really quick. We have one of those guys at our company right now. He's just like, I just go to the docs. I just go to docs.spark.org or whatever the technology is. He's like, that's just what I do. Then
Right.
yeah, I would start with Spark, Hadoop, Kafka if that's what interests you. But if that's something that you can do and that's how you learn is just ingesting data and just spitting out widgets, that's totally up to you. But yeah, so I would also say from a Kafka perspective, in kind of they have a really good blog series on Confluent.
Mhm.
The Confluent blog posts are great. You're like, hey, you guys have like name dropped so many different things, like event-driven architecture. What the heck is that? Well, they really go into like Ben Stofford has a really good 7-part series on event-driven architecture and what breaking apart the monolith looks like, and what does that mean in today's architectures, and that's super critical. I know some other things that we've talked about, and I really haven't had as much experience, but maybe you have, Kalen, is Databricks, and just they're crucial to the big data sphere. And I know they have some of the best documentation on Spark itself, because I think they actually came out of, like, they founded Spark, right? They're like how Confluent is to Kafka, right? Databricks and Spark, they go hand in hand.
For sure. So this is a podcast, so I'll give a funny story. And it was my introduction to Databricks, right? So I had a talk, this was like 6 or 7 years ago, I think. I had a talk at a conference called Datapalooza in San Francisco. And I think it was like real-time vehicle telemetry or something like that. And I didn't know that IBM was investing so heavily in Spark and Databricks. And so we go to Datapalooza, and we give our talk and all of that, and I go back to my hotel, and then there's the after hours kind of party or whatever that was set up, and they rented out like a ballroom or something. There's like 3 open bars and a 7-course meal, and it was set up right. They also had a band that was playing, and the band that was playing at the time was the Big Data Band, which is a real band, by the way. There's a real band called the Big Data Band, and
Hold
somehow
on. Google's feverishly big data
yeah,
band.
so somehow the singer has some kind of relation to someone in the big data space when he was in college or something like that. I don't know, but they were on tour in New Jersey, and they flew them down to San Francisco for that night to do the show and then come back. And so it just so happened when I got back to the hotel, I found the venue was like right behind my hotel, so it was walking distance. I just walked back there, and there were, I don't know, like 80 people there. It was nothing. Like nobody showed up, but you could tell the money that IBM put into this, Databricks put into this event was crazy. So they were handing out free tickets after a while just to get people in to make it look like it was busy. But that was my foray into, oh wow, money's actually being spent pretty crazy into Spark. And you're right, Spark was created. The founder of Spark was created by one of the, I think it was the guy that actually invented, or the founder of Databricks was the guy that created Spark, I'm pretty sure. And so Um, Databricks itself is really good if you're starting out, right? Because you can get clusters. You can spin up a free cluster there. I think it's a 5 GB cluster they let you spin up for free, and they give you a notebook, right? A notebook is a little bit different than, well, not a little bit, but quite a bit different than writing an application. But it gets you the idea. You can use, I think, PySpark API within Databricks. And so you get an idea how to ingest data, what options you have to manipulate or run a machine learning model, and then save that data back out to different places. So it's super convenient when you're starting up. But yeah, lots of momentum with Databricks. Lots and lots of momentum with Databricks.
Yeah, and then I think some other things that you could look for. I think you were saying Google has some free data sets that are pretty massive that you can start playing around with. If you look on GitHub, there's some also massive data sets. Amazon has some large data that you can start playing around with, because really you're not, if it's on your laptop and it can fit on your laptop, you're really not testing your applications that you're developing appropriately and at scale, right?
Right.
So just for all of the people who are trying to enter this space, or maybe you're in this space and like, hey, I think I'm working on big data, but maybe it's not big data. Maybe it's big data for my company, but like it's not Google big data.
Yeah.
But yeah, if it fits on your laptop, probably don't consider
Yeah.
it big data.
Yeah. Definition, big data definition will vary from company to company, but like the good bar is always like Nate just said. If it fits on your laptop, it's not big data whatsoever, right? We're usually when we're talking about big data, we're talking about either continuous streams of data, 24 hours a day, 365 days a year, to very, very large batch sets of data, petabytes large, petabyte, and things like that. In fact, we just gave a meetup on last Thursday, and this comes to mind. Our slide was data is the new oil, right? And it really is. If you've seen data marketplaces right now, which is where those free data sets were offered through Google, their Google Data Marketplace. There's some free ones, but a lot of them are paid, right? People are just buying data. It doesn't matter. So lots of data marketplaces are going up right now. And there's more and more data is being created all the time, especially with the proliferation of devices and IoT, from everything into refrigerators to, name it, there's a device inside of it.
I know one
I
of the big, sorry, I didn't mean to interrupt. One of the big things that in the utility industry was uh, meter data. Like what type of information can we get off the meters to more accurately predict the stress on our system as a whole, and how can we react more quickly to that? So IoT data was huge in that space.
mm-hmm, mm-hmm. Yeah, it's so interesting, especially with machine learning these days and AI, because prior to that, think of it this kind of anecdote, right? Like prior to the AI days, if you and your family went on a vacation, say, you went to a hotel and you paid a bunch of money for that hotel, way more than your normal Motel 6, because you want your family to have that experience. Then you come back the next year and they know you, right? And so when your kid gets out of the car, the valet has, his favorite candy bar there for him, right? They've got your towels colors or whatever, right? They've got your stuff inside of your hotel room that you liked last time, and that was the service you paid for. That extra bit, that extra attention, people would pay immense amounts of money for that customization just for you, sort of mentality. Now that's almost expected, right? In everything that you do. Alexa is a great example of that, right? I want to know this immediately, or I'm going to, order my car service or whatever, and I just want to be able to say it and have it show up, right? So there's the I'd say it's the convenience industry almost in B2C apps, or B2C AI apps is super, super popular right now, and those are going to explode over the upcoming years, and layers on top of those. Maybe Alexa doesn't give you exactly what you need, right? But there's a company that's going to come on and layer on top of that to form out what you need, whether there's a human in back of it or not, to give you that service. So it's interesting how those machine learning models are providing services today that you had to pay for, like a bunch of money back then. But the only way to make tune those machine learning models correctly is by having and collecting as much data as you possibly can. So every company these days is pretty much turning into a software company. We hope that most dive into the data space, because if you're turning into a software company and you're not saving data, then you should be, right? Because data is value these days. Maybe it's not obvious to whoever's collecting it now, but somebody will pay for that data. So I don't know. The world's going in an interesting way. I'm excited to see what comes in the future. But the subject of this podcast, learning big data, is fundamentally very important, because there's so many resources out there that if you were just to Google, I don't know how well you would do. For me, my foray into it at least was, the Apache websites at the time, and then just client experience, which means I was kind of like thrown into the fire, and I had to figure it out. And I think we all are at some point within this industry. At some point, you're going to be put into a position where you're like, I don't know how to do this tool. I don't know how to work with this API. But you get there.
Yeah, I think some of the best software engineers that I've ever worked with are always those that are just constantly trying to learn something new, just constantly trying to grow themselves. And for any new developer or someone who's just entering the space that's listening, I would really just encourage you. Like Kaylin and myself, we don't know it all. Like we put in the effort and the work to learn things and to ingest bits, but the core software engineering principles and the core constructs of languages and technologies is what like the basis of all of these things build out. It makes it easier to learn and ingest new data, right? So like how does Pulsar differ from Kafka? How is HDFS used in Hadoop? I mean, they're all core constructs, right, that have been established probably
Right.
prior to the 2000s in some cases.
Yeah.
But yeah, man, stay hungry, keep going after what you want to do.
And I would expect to turn into an amateur architect too, right? Lots of times when you're just developing software, you don't, maybe it's a MVC application and your infrastructure is that database that you really have to think about. But whenever we're creating a big data application or a data intensive application, we're working with APIs from Hadoop, Spark, Elasticsearch, Kafka, tons of different things. So that passion has to be there that you talk about, right? That passion has to be there. The homework passion has to be there, because I mean, you have to live and breathe it, right? Like I always bring it back to grad school days. The only way I got through that was by living and breathing mathematics 24 hours a day, going on to mathematics, subreddits, reading as much material as I possibly could. And then when I got into the big data space, that just translated right over, right? So even when we bring on new people, right, it's very hard to it's very hard to determine the capacity, but that's the most important part, is the capacity to learn quickly. So we look for people that are reading blogs all the time, tech meme, TechCrunch, Hacker News, that kind of stuff, and that are interested in trying out technologies that may not even be related to big data. They're just new, right? So keep hacking away at it. Try to get your foot in that door. There are a lot of materials that are open on different learning sites, but most importantly, just like learning how a radio works, get your hands dirty and get some stuff down, even if it's at a very small scale. Break it and fix it, right? Like that's essentially how everybody learns. I think is breaking and fixing for the most part.
Yeah, definitely. Any shameless plugs before we wrap up? You're on Twitter, right? Kaylin Humphreys.
Twitter, right? Kaylin HU on Twitter, Enfuse on Twitter, Enfuse.io, Enfuse.io on Instagram, Enfuse YouTube now after this video, right?
Yep. Oh man, get my mug on there.
And our podcast will be up. Of course, our website is sitting behind me. We just had a meetup. That's got to come off. But that was a lot of fun to do this. So that video might be up again on our YouTube channel as well at some point. And then I think the next podcast for us will probably be, we'll probably try to do what do you think, like a bi-monthly kind of thing, or once a month?
Yeah, I was thinking we'll see maybe bi-monthly, and I think our maybe next topic that we're going to go into might be a lot of people talk about big data being dead, and like I don't think that's the case at all. So we kind of want to debunk that myth and really
Mhm.
dive into what are people talking about. Maybe it might be uh, sects of big data, right, that are no longer leveraged as heavily, but
Wow.
big data itself is thriving, as you can see.
For sure, for sure.
Yeah,
If you're a data company, you're collecting that data and it's going somewhere and it's getting big. So
yeah, cool. Well,
awesome. Well, thanks for listening, everybody. Any little kinks that you do see with this first podcast will hopefully be ironed out. The better we get at this, and we'll try to keep up a good cadence of releasing these things to help that podcast hunger. And who knows who might be on the next one? We might have a third person on here as well. So we'll see.
awesome. Well, thanks, Kalen. Appreciate you, and thanks to all the listeners for listening in. Enjoyed it.
Absolutely. Talk to you guys later.